Hi everyone, I'm Rui Liu and this is my group member Junqia Liu. Our group topic is home credit default risk prediction. It is to predict the default rate one may or may not return the loan he borrowed from the company. Here is our outline. First, we will give a brief introduction about what we did from milestone 1 to milestone 3. Then we will introduce the web page establishment. Finally, we will present a demo for our final project. Our data are from the cargo computation. It is a complex data set with one main spreadsheet and 7 other complementary spreadsheets to provide more information. It is more than 2.5 gigabytes in total. From milestone 1 to milestone 3, we went through data cleaning, feature engineering, model selection, hyperparameter optimization, and final model ensemble. In the feature engineering step, other than normal feature engineering methods such as hotkey encoding and label encoding, we created many features based on the following 3 criteria. First, we put time features in a more logical way. Second, based on other subjects' knowledge, especially economics knowledge, we create features which make more sense. Third, we combine useful features together, especially the features which are significant in the model. Our final dataset has more than 700 features, and all these features improved about 1% of our result. This is an example of hotkey encoding, label encoding, and put time features in a logical way. This is an example of using economic knowledge to create new features. And this is an example of using useful features to create new feature. Next, we did some model selection based on some baseline models. From the plot, we can see that LightGBM performs better than other models. So we will use LightGBM as our model. Next, we feed our data into the model and used five-fold cross-validation to estimate the text error. Then we optimize our model hyperparameters using sequential model-based global optimization, which is also called Bayesian optimization. Then we did model ensembling, and you can see from this plot that we improved our model performance from 0.78 to 0.8, which rank top 20 on the leaderboard.
Recall previous presentation, we've drawn the figure to represent the website of our project that we are going to build. And now we have already built our website. And our website is based on Django and written in Python. It is a high-level Python web framework that enables rapid development and clean, pragmatic design. And to do the data visualization, we use eChart, which is an open source project of Baidu. It is a declarative framework for rapid construction of web-based visualization. And this is the system architecture of our project. Basically, it is divided into 3 parts. First part is the setting of the server, and the second part is the part of the baseend, and the third part is the static part, which contains the CSS file, HTML file, and the image. And this is the homepage of our website. The input is the applicant ID that you want to search, and if the ID is not contained in our dataset, then it will reload the homepage. If the ID is contained in our dataset, then it will direct to the report page. And for our report, it is also divided into 3 parts. The first part is the information of the user. We represent some info in different color. For example, for the prediction score, for the number between 0 to 0.2, it will be shown in green. Between 0.2 to 0.6, it will show in yellow, and between 0.6 to 1, it will show in red. For the gender, male will show in blue and female will show in pink. The second part is the plot of the previous application of loan of this applicant. The data is grouped by the application ID, and there are four kinds of bars showing the plot. The red bar is the end date of the application. If it is negative, then the value means that this loan is finished for that days. If it is positive, then it means that this application is not finished yet. The dark blue bar represents the start date of the application before this applicant start this application on the home risk. The orange bar is the total amount of the loan, and the light blue bar is the amount of unpaid loan. And the third part is the credit card balance plot. It represents the amount of credit balance every month before this application. If the amount is lower than 10,000, then it is showing green. If it is between 10 to 50,000, showing blue. 50,000 to 100,000, showing yellow, and 100,000 to 500,000, showing red. Here is the website we will deploy it on the virtual machine, and I will show you the demo. You can use this URL to try the demo too. Notice that there are some IDs are not continuous because the data is from the data set. So we can put the ID, and now we can show the report. Here is the previous application of loan, and here is the credit card balance plot. You can show it like this, and you can click here to return to the home page. Okay, that's all. Thank you.